Hi, welcome back to the intro set. And this video, we're going to work on the lab number 3 assignment, how to do a box plot. Before we go into the program part, let's just continue what we did in the class. So let's finish the lecture part. So today, this video, we're going to talk about the 5-number summary and also how to construct a box plot here. All right, and so let's go ahead and go to our lab lecture notes and let's continue what we did in the class here. Okay. Okay, here's our note for our lab. We have finished all this. And now the last things here, we talk about how to measure the spread by using the range and the IQR and the standard deviations, right? Okay, so the last part of this lab is how to construct the box plot. So in order to do that, so let's first go ahead, take a look what is a 5-number summaries here. All right, so the 5-number summary here, so it's just like what we have in this graph here. Okay, so in this things here. So those 5 numbers are my 5-number summaries. So we have a minima value, then we have a Q1, then we have a median, and we have a Q3, and we have a maximum value. So basically it's these tables, right? So kind of refresh the memory. Q1, this we call this the first quartile, correct? Or you can say it's the 25th percentile. Then the median, we can use it, we can say this is our second quartile. Or you can say this is our 50th percentile. Then the Q3, you can say this is our third quartile. Or you say this is our 75th quartile. Right, so that is a very simple summary. So that's why we call it the 5-number summaries here. All right, so what is the box plot here? Okay, so box plot is basically a graphical display of my 5-number summary. Okay. Okay, and the other things here we need to be very careful. So the box plot is very, very useful. That's probably is the one of the main benefit or advantage is particularly useful, when we try to comparing groups. Okay, so when we try to comparing groups and the histogram, probably not the box plot probably is very, very useful because you can compare many groups like 15, 20, you'll be able to put them in one piece of the paper. If you try to do histograms, then it probably is very difficult to put more than 3 or 4 histograms in one piece of the paper. So that is the biggest advantage of the box plot. It's very useful for comparing here. All right, so now here let's take a look. How do we construct a box plot? Since we said a box plot is a graphic presentation of this 5-number summary, so let's use this 5-number summaries as here. Try to use this as an example to do it. Okay, so the first thing here is that draw a single axis, all right? And this axis here, you draw a single axis. This axis here can be vertical or horizontal axis. And the reason, so you'll be able to do a vertical box plot or a horizontal box plot. So later, when we're doing the R code, we're going to have different codes. If you want to do a vertical, then the code you want to do a horizontal here. So first thing is you draw an axis spanning the range of the data. And then you draw a short line at the lower or and the lower and the upper quartile and at the median, and then connect them to form a box. Okay, so now let's take a look by using this example. So in here, I'm going to do a horizontal. All right, so what do they mean? Find a single axis spanning the range of the data. So I know my smallest one is 3.7, largest one is 9. So I said, okay, probably what I would do is I would say, okay, so now I will do a horizontal. Okay, so I will say here, oh, well, hope I can do a better graph here. All right, so that's better. Okay, so now, all right, that's fine. Okay, so this is the line. Okay, so because the smallest one is 3.7, so probably I will start at 3. Then here is 4, 5, 6, 7, 8, 9, 10. So I draw a line and then I cover the whole range from 3.7 to 9.0. So then the problem tell me draw a single short line in the lower and the upper quantile and the median. Okay, so here is what I'm going to draw here. All right, let me give it a different color. Okay, so the first quartile is 6.6, so probably it's somewhere here, right? 6.6. Median is 7, so I draw a short line here. Then the Q3 is 7.6, so probably it's somewhere here. Then I connect them and so form a box. That's what is the first statement talk about. All right, so that is the first one is draw a single line at the 25th. So this is my Q1s, right? And this is my Q3, right? And this is my median. Okay, so then the next thing here is we need to construct, we call it is the fence here. Okay, so the fence around the main part of the data. Okay, so what is the fence? So let's write here. So the upper fence is 1.5 IQR above the upper quartile. So the up fence is 1.5 IQR. So basically the upper fence, so the upper fence is equal to Q3 plus 1.5 times IQR, right? And the lower fence is the 1.5 IQR below the lower quartile. So I know the lower fence will just be the Q1 lower, so it's 1 minus 0.5 times IQR. All right, so here be careful. This is Q3 plus. This is Q1 minus here. Okay, so then they put a note here. They say the fence only help with the constructing of the box plot and should not appear in the final graph. So like in the box plot, you will never see a fence. So because after we use it, we'll erase the fence because that is only for the to help. All right. Okay, so now let's take a look at how do we use this data to do an upper fence. Okay, upper fence. So first thing is here, the IQR. IQR is Q3 minus Q1. So it's 7.6 minus 6.6, so it's 1. Okay, so upper fence will be Q3. So it's 7.6 plus 1.5 times 1. That's right, because IQR is 1. So what is my upper fence here? So my upper fence will be 9.1. And now I'm doing my lower fence. So the lower fence will be Q1. So it's 6.6 minus 1.5 IQR minus 1, right? So my lower fence here will be 6.6 minus 1.5. So will be 5.1. Okay, so now let's do it. Okay, so here we said, all right, let me do a fence here. Okay, so first one is 9.1. Okay, so probably here. So like I said, we do fence just to help. So I just dot that. And then lower fence is 5.1. So here is our fence. Okay, all right. So that's what is the second part they try to tell you. Okay, so now the third one is interesting. Use the fence to grow whisker. Okay, so that's why sometimes the box plot is also called the box and whisker plot. Okay, so here this is what we do. Draw the line from the end of the box. So from the ends of the box up or right. So it depends on which, the box plot you use, you use horizontal or the vertical. So if you go this one, this is a vertical. If you go right, that is the horizontal. Okay, and down, or we say left, the same thing, depend on which his box plot you do, to the most extreme data value find within the fence here. So this is the probably is the most important statement here. So it's the most extreme value within the fence. Okay. So then if data fall out of the fence, okay, then we do not connect it. So if it fall out of the fence, we do not connect it with the whisker here. So add the outlier for the old value beyond. beyond the fence with a special symbol. That's what we call the outline. Okay, now let's take a look here for these numbers here. Okay, so I'm growing the whisker right now here, all right? So this dotted green line is my fence. I looked at here, I said, oh, my largest number is 9.0. 9.0 is the largest number within the fence. So I know I can grow my whisker all the way to here. All right, so for the left here, okay, so for the left here, I know my minima is 3.7. So 3.7 is outside the fence. So I cannot grow the whisker all the way to 3.7. So 3.7 is outside the fence, so it's an outlier. So I will use some special, I use a star to represent the outline. So where is my whisker stop? So from this example, because I only have a summary, so I don't have the raw data. So I don't know what is the smallest value, they still within the fence. So, but the computer, when you input the raw data, they will be able to see. So your fence probably can go like in here. So because Q1 is 6.6, so probably your whisker can stop here. Like I said, this is the guess because in here, I don't have detailed data. So I will guess that's what that means. You use the most extreme value within the fence. Do I have any more outlier? Yeah, very possible. Just because I don't have the data, I don't have the detailed data, I probably can maybe have a couple other outliers here. I just don't know here, right? But with the computer, they will be able to search through the whole data set and find it. Okay, so that is a box plot. So after you finish this, you just erase the what? You erase your your fence, right? So you erase your fence. So the fence, the fence is 4, 5. Okay, so the fence doesn't show up. So that's why I know based on this data, I have one outlier, and in here, where is my whisker grow on the left-hand side? From my data, my summary data, I don't know. But, with the whole data set, the R will be able to correctly identify where is the whisker. All right. So this is what we call it a box plot. Some people call it box and whisker plot. All right, so now remember we said one of the biggest advantage of the box plot is comparing. It's very, very the key things for the box plot. So box plot provide an ideal balance, okay, of the information and the simplicity. Okay, hiding the details while displaying the overall summary. Right, so that is the benefit of the box plot because in order to compare so many groups, we need to balance out how much information I want to displayed, and I don't want the graph to become too complicated. So that's why it's a balance about how much information you want to show and is the graph simple enough. All right. So like in here, so this is what we call this the vertical. All right. So this is the vertical box plot. So in here you can see I can compare for 12 different groups here. And because it's a very simple graph, so you can see, so for example, in the February average wind speed for February, they have a pretty big ranges here, right? From the maybe 1 to 4. But if you take a look for the July, have a very, very tight variation. And once a while have an outlier here. All right, so once a while they have an outlier here. So it's easy to compare, the groups here, especially like right now, we compare the 12. If you do that, we can compare up to 20 or 25. And so because it's the simplicity of the box plot here. All right, so that's it for this videos, right? So our next video, we're going to work on the R statement here. How do we do the R code for that? All right, that's it. And so I guess I will talk to you next time. Okay, bye.